Assalamu alaikum friends and welcome back to the course. This is a bonus video, you can skip it if you want. We are talking here about mutation testing. So what is mutation testing and why we would need it, right? So if you go here to my test, let's say pretty much any test, right? And we want to see if this test is actually testing something, right? Sometimes we can have a code coverage 100%, but you are just covering the code. You are not exercising different cases. Let's just pretend, for example, something, right? I can go here. Let me just stop this coverage. Let's pretend like our test is testing this one, is passing from this side, right? And let's pretend I'm changing the minus here with a plus. For example, this is just an example. What do you expect should happen? Some tests need to break, right? Let's run the test and see if our tests are breaking. Exactly. A lot of them are breaking. Of course, some are passing, some are not. And this is the expected case. Like, that's the point from the test. They are safety net for us. So when we do some mistake like that, we will get alerted. That's a good thing. But let's say the test passes. It means simply our tests are not good enough. They are not testing something. They are covering this, but they are not testing something. For that reason, a lot of the people don't like a lot of coverage because it doesn't tell a lot, right? And in order to see if our tests are good, of higher quality, of course, and also if you want to improve them, we can do something called mutation testing. I'm going to use PyTest, which is a good library for doing mutation testing. What it will do the following. It will try several stuff. It will come to your production code and it will try to change something. It will, for example, change this smaller or equal to greater or equal, for example, and see if the test passes, it means there is a problem, like this shouldn't pass. If the test doesn't pass, it means we are good. It will do this for a lot of the points in your code, and for every one of them, it will rerun the tests. Why we call it mutation testing? It's kind of we are doing mutations in the code. We are coming here and replacing this one with a plus, for example, like we are adding point of mutation. And there is concept of mutation killed or survived. If it survived, it means the test passed, right? So we added the mutation and the test didn't catch it. So it means the mutation survived. Otherwise, it is killed. You can check my YouTube channel. I made a full video about it. You can check it for more information. Now I need to reset this and let's see how we can use mutation testing in this project. So to start including mutation testing in our project, we need to go to the build gradle file and we'll try to add it as plugin. Here we have the plugin like following. This one, and we are going to have specific configuration for PyTest. Here I'm going just to paste it because I'm using previously. So there are a lot of parameters here. I explained these parameters in details in my YouTube video. So here there is something called mutation threshold. So the mutation threshold is below which the test is considered as failed, right? There is this coverage threshold, same thing for the threshold. And here we do have some parameter setting for the threads because this is an extensive task. You know, we need to add the mutation, run all the tests, record what happened, and then add another mutation, record what happened, and something like that. Then we do have the mutators. There are many mutators, you are going to see all part of them. And here we do have the target class and also the target tests, right? So the tests, everything is here. And also the output formats, and don't include anything specific to Kotlin internals, okay? So just resync the project after including the plugin and this one, and it should work. After the successful sync, go here to Gradle task, and here check for the task. There is something called verification. Here you must see something called PyTest, okay? Just run it, and then it will start the testing part. It will be a huge thing, we're going to see in a minute. There are some parameters you can specify for the verbosity of this plugin to tell you what is happening exactly. So the test completed successfully in 33 seconds, which is big time. So here it will tell you what happened exactly. Here are some of the mutators we use. The mutators, for example, remove conditional mutator, or the else, for example, it will come to your code, and whenever there is an else, it will remove that part of the else and expect some test to fail. Okay, this is called a mutation. It generated 39 mutation and it killed 35. And it means there are 4 mutation our test didn't catch, which is a problem, right? Same thing, there are many mutators. For example, primitive returns are going to see some of them. Conditional boundary mutator. These are some mutators. You can specify which mutators you can use in your project. In our case, we use stronger. It means a lot of mutators at the same time. Okay, so these are all the mutators. You can go a little bit down to get full reports. Here are the line coverage, which is pretty much good line coverage. Here are the generated mutations and how much it killed. Usually 80% is pretty good. And here we have something called test strength. Usually 80% is pretty much good. Here are the total number of tests. In order to see the reports, you can go to the build here and go to reports. Here they have PyTest, and here we have an index file. You can open it. We can open it with IntelliJ built-in browser. So here are the reports. It will tell you the mutation coverage, the text strength, and so on. You can go here and the prior time calculator, and here you are going to see what mutators happened exactly. All right, awesome. Here, whenever you see something green, it means it generated a mutator and then it killed it. Here, it didn't kill it. For example, there is this one remove call mutation. What it does, it will simply try to remove this line and it will run all the tests and expect it to fail. Okay, so it didn't fail. It means this method is doing nothing. What you can gain from such an information like that, it means this method is doing nothing. We can remove it because this one is setting the calculation method to 0, right? And this is the default value where you give it to int. These are pretty much the same thing. If you go a little bit down, here for example, 3, it means it generated 3 mutations, right? Replace double division with multiplication. Where is double division? This one. We replace this one with multiplication and our test failed. It means you are doing things correctly here. Here, the other stuff, replace multiplication with division, replace subtraction with addition, it is passing. Now for this one, it generated 4 mutations. And as you can see, some of them were killed, some of them were survived, and some of them, we don't have any coverage for them. For example, we changed the conditional boundary. Here, changing the conditional boundary, it means we are flipping this one, or maybe doing this one and putting it here, like conditional boundary, because this is condition, right? This is called ternary operator. We don't have this in Kotlin, unfortunately. We have if and else, normal if and else. So as you can see, this line has a problem. It means you should include some kind of a test that will cover this line, all right? For example, here, one of them we didn't pass, which is replace comparison check with false. So what we did here, we did false. It means this one didn't work. I think something like that. And from this kind of information, we can get back to our test and fix our test or add some test cases that will bring much more strength to your tests. Okay, I'm not going to take any action for that because this is bonus section, right? I just wanted to tell you that we have something like that. Here, for example, we generated 12 mutations. A lot of them were killed and a lot of them didn't pass. Change conditional boundary didn't pass. Replace comparison check with true didn't pass also, which is pretty bad thing. And I think this technique, because this is a technique, right? The pit is the tool and the technique is mutation testing. There are frameworks in a lot of languages. Unfortunately, we don't have it in Android directly. We have it in Kotlin, but in Android, it's a little bit different because we are targeting the DVM, not the GVM. This is a little bit problematic. So maybe in Android, you can separate specific package that uses only Kotlin and apply such tool for that. So feel free to use this one and add specific test cases into your unit test. This is perfectly fine. Here at the end, you are going to see all of the mutation and the lines, code lines. Here you are going to see many mutations, the one that didn't pass and the one passed, killed and survived, of course. And basically you can take action upon that. Maybe you can modify the code source or you can modify the test, add some tests to satisfy some confidence level for you. I'm confident enough to start refactoring. Okay, that's pretty much for this video. In the next video, finally, we are going to start refactoring. We're going to start by converting the Java to Kotlin. That's it. Thanks a lot and see you in the next video.